At the University of Wisconsin-Madison, we are engaging in a very exciting interdisciplinary activity between computer science and medicine. Our product is a computer-aided platform which allows surgeons in training to rehearse, plan, and experiment with different surgical procedures before actually trying them out on a real patient. The research program is called the Skin Biophysics Surgical Simulator.
One way to think about our tool is as a flight simulator for surgeons, where they can practice the operation without putting the patient at risk. The current practice with training medical students is relatively low tech. The hope is that our system will provide a cleaner, more illustrative resource that will clearly demonstrate what's happening during an operation. So similar to how flight simulators provide a safe virtual environment for pilots in training while not putting the plane or passengers at risk, our tool will do the same for surgeons in training, allowing them to experiment with operations without putting the patient at risk.
It is a little bit surprising to me why a system like this has not been already deployed. In some sense, all of the technological building blocks are already there.
We've made considerable progress on this tool since we started several years ago. We have expanded from very rudimentary applications to something that is now deployable on a network and can stream surgical operations to your ordinary web browser. Moving forward, we have a lot of work to do yet to make the simulation seem more realistic.
Part of the funding for this activity originates from the National Science Foundation and the National Institutes for Health. Our pilot prototype focused on surgical procedures on the human scalp. Our next iteration, which we hope to deploy in the next year, is going to focus on the lower face, and then we also hope to extend to other parts of the body. We are striving to make our simulated materials essentially exhibit the same limits of elasticity and strain as would be observed in real tissues.
The goal of our tool is to provide students with a virtual environment to experience operations from start to finish, with the possibility of interactively altering the design of the operation, seeing how the operation succeeds and fails under certain circumstances, and potentially replaying previously recorded operations for purposes of training or evaluation.
We essentially want to provide an environment where the vision of the surgeon can be translated into an actual 3D animation in a matter of minutes. Imagine it as a paintbrush or the Photoshop for surgeons, where they'll be able to directly illustrate what their surgical maneuvers need to be. I have to credit my senior surgeon collaborator, Dr. Court Cutting. I've been very fortunate to also partner up with Dr. Timothy King. It is very important to have very close collaborations with the actual consumers of the product.
So late in 2014, we exposed the tool to a group of surgical residents here on campus, and we basically ran them through a demo of how the system would work.
All of the residents felt pretty comfortable relating to digital models of anatomy in a computer setting.
So we received lots of positive feedback from the residents. Many of them had great comments about how to improve the visual appearance, and these are all going into future iterations of our work.
I think that this early pilot exercise kind of reaffirmed our belief that there's a glaring gap that a system like this is in a position to fill. So fortunately, this is not the only activity that tries to place computer-aided simulation in the service of medical training. However, I would say that the unique perspective of this particular work is that it does not focus on the tactile aspects of what it feels for a surgeon to cut skin. I would consider that as a complement to our own activity, but the specific nature of our work has to do with the fact that we're concentrating on generating three-dimensional shape by using cutting and suturing as the building blocks, and also using the simulation of real tissue mechanics in order to aid the user of the system. So my vision is that this product is going to improve the quality of patient care by offering the clinical practitioners a better platform in which to exercise and hone their skill.
So the long-term potential of this research is really bright. I think what we've got at the moment is an excellent foundation, and now we just have to build something incrementally, piece by piece, on top of that until we're at the place where we want.